Alright, so let's start studying propositional logic. So first, what is a proposition? It is a statement that can be either true or false. So there can be only two values, two possible values, true or false. And true is represented by this symbol, like T. Okay, and false is denoted by this symbol. It's opposite of true. Okay, for example, 1 plus 1 is equal to 2. This is a proposition, and we know that its value is true. Yeah, it's true. Another example, 2 plus 2 is 5. This is yet another proposition, and the value of this proposition is false. And proposition can be any kind of statements, which can be either true or false. So, for example, we can say it's raining. So this is a proposition because it can be either true or false. Right now, from my room outside the window, I can see it's raining. So at this moment, in this particular place, it's true. Okay, so that's proposition. Now, if we have two or more propositions, we can combine them in certain manners. For example, 1 plus 1 is 2 is equal to 2, and 2 plus 2 is equal to 5. So this and this, so this is yet another proposition. So just to make things simpler, let's say this proposition is represented by this symbol P, and this proposition is represented by symbol Q, these words. So we can say P and Q. So this looks like another proposition, right? And we call it conjunction. And write as P and Q. So this symbol represents logical AND. Okay, so each of these propositions Q and P has some truth value, true or false. Okay, so these are truth values. So if we know the truth values of each of P and Q, then what is the truth value of this P and Q? It is defined by a table called truth table. So in the case of conjunction, we write the truth table like this: P and Q. Okay, so when P is true and Q is true, P and Q is true. When P is true, Q is false, P and Q is false. When P is false and Q is true, then P and Q is false. When both are false, P and Q is also false. So conjunction it can take the value of true only when both of Q and P are true. Okay, this is the only case. Otherwise, it's always false. That's conjunction. In addition to conjunction, we can also create a new logical statement like P or Q. And this is called disjunction. And we write this as P, this, Q. Okay. So when P is true, oh, and Q is true, then what's the value of this? P or Q, is it true or false? And this is again defined by a truth table. P O Q. So this is the definition. T, true, true. When both are true, this is true. When P is true, Q is false. P or Q is true. And P is false, Q is true, then P or Q is true. When both are false, then P or Q should be false. Okay, so this is the truth table that defines disjunction. Okay, so in this case, if either P, at least one of P or Q is true, then the disjunction is true. When both are false, this is false. So this is the only case where disjunction is false. So for example, let's recall these two statements. 1 plus 1 is 2 and 2 plus 2 is 5. So let's say this is P and this is Q. So in this case, this P is, the first statement is true and the second statement is false. So we pick this row. So the resulting proposition is true because at least one of them is true. So this is true. Okay. Yet another operation on propositions is negation. That means if P is a proposition, negation of this is not P. So it's a negation of this proposition. And we write this as this symbol and P. So this is, we read not P, not P. Okay. Unlike conjunction or disjunction, this operation is operation acts on only one proposition. Okay, it's not pairwise, it's just one unary operation. And this is defined by the truth table like this. P and not P. If P is true, not P is false. if P is false, not P is true. Easy. Okay? Again, for example, we have 1 plus 1 is 2. Let's say this is P. So not P is, this means not 1 plus 1 is 2. So that is to say 1 plus 1 is not 2. So if this is true, what's the value of this statement? If this is true, then this is false, just like this. And try the same argument with this statement. So since this is false, its negation, is true. Okay.